Hello there! Some rock formations are formed over billions of years ago. Take this rock for instance. The way we measure its age is with radiometric dating. Radiometric dating is a method to find the age of rocks and fossils. This method is especially important because it precisely measures radioactive isotopes' time to half-life.
The radioactive decay of an element is essentially a random event. Radioactive decay occurs to a quantum process occurring within the nucleus of an atom. The end result is that we cannot predict when a particular radioactive nucleus will decay. However, we can make a statistical statement as to when it will occur. We can measure the time taken for half of a large sample of radioactive atoms to decay. This is also known as half-life, or T-half. Consider a sample of 8 million radioactive atoms with a half-life of 20 minutes. We start an experiment at T equals 0. After 20 minutes, half the sample, 4 million atoms, remains undecayed. After another 20 minutes, 2 million atoms remain undecayed, and so on and so on. We can express the proportion of the sample remaining as current amount over original amount equals 1/2 with the exponent of T over T-half. In this case of rock dating, T is the time since the rock was formed.
The equation we're using to find the age is T equals T-half F times log base 10 current over original over log base 10 to the 1/2. And the example we're using is we're going to analyze a meteor rock with the potassium 40 and argon 40, and the ratio for potassium 40 is 0.85 units, and for argon 40 it's 9.15 units. So how old is the meteorite? And argon 40 was potassium 40 that decayed with a half-life of 1.25 billion years, and the original amount of potassium 40 was 0.85 plus 0.915, which is 10.0 units. And so you plug it all into the equation we use is T equals 1.25 billion years times log base 10 0.85 over 10.0 all over log base 10 to the 1/2, which comes out to 1.25 billion years times negative 1.07 over negative 3.01, which equals 4.45 billion years, and the meteorite solidified 4.45 billion years ago.
And that's how radiometric dating is used to identify a rock's age. You're not that old.
We predict due to radioactive decay, the environment can affect the aging of rocks. Also, that exhaust from cars and pollutions from factories creates an acid rain, which affects rocks tremendously. Since rocks are affected, the results could vary due to radioactive changing.
Radiometric dating measures elements of half-life, which gives us the precise age of a rock. So remember, when you pass a rock, it could be billions and billions of years old. Thank you for watching. I hope you learned something today.
Okay.
Oh, hello there! Some rock formations are formed over billions of years ago. Take this rock for instance. This rock years ago. Take this rock for instance. The way you would measure. Hello there! Some rock formations are formed over billions of years ago. Hello there! Some rock formations are built. Hello there! Some rock formations are formed over billions of years ago. Take this rock for instance.
It's T equals half F at times. Damn it, I keep saying X. Okay.
Okay, go.
T is the time since the rock was formed, and the equation is T half F X.
However, we can make a statistic. However, we can make. The radioactive decay of an element is essentially a random event. Radioactive decay. Okay. I'm gonna start over. The radioactive decay of an element is essentially a random event. The radioactive I don't know what to do.
That was good.
Did
I
you see
even
the
do it.
whiteboard when you turned? Okay, because I was like, oh my god, I thought you could see the whiteboard.